Hi everyone, welcome back to the session. Am I clearly audible to all of you? Please confirm. Perfect, cool. So let's get started. In the session yesterday, we explored some good number of security mechanisms. We started off with understanding some STP concepts, where we looked at concepts like port fasting, BPDU guard, root guard, and then port security. Later on, we tried implementing DHCP snooping, as well as looked into ACL, standard ACL. Today, the very first thing that we are going to learn is extended ACL. So let's get started. Let's understand what is an extended ACL and how it can help me in filtering a specific protocol from making communication between the devices. I'm going to create a small scenario here. I'll take two routers and will connect two switches and some end devices. Let's connect all these devices together. Like this. Oh, I'm so sorry I missed on sharing my screen. My screen must be visible now. Yeah. So I just have installed some devices and made the cable connections. And now we are going to configure them. So this network will be, let's say, 192.168.1.0/24. This will be 192.168.2.0/24. And between my routers, I'll use 12.10.1.0/24. To connect these devices together, what I'll do is I'll put both of them into EIGRP 100. Like this. Let's begin the IP configuration. I'll go to the CLI, say no to the question, enable config T, host name R1, FA00, IP address 192.168.1.1/24. No shutdown, exit, FA01, IP address 12.10.1.1/24. No shutdown, exit. Then I'll create a DHCP pool, IP DHCP pool A for my network 192.168.1.0, 255.255.255.0 with a gateway address of 1.1. Next, I'll go to my router number 2, CLI, say no to the question, enable config T, host name R2, interface FA0/0, IP address 12.10.1.2/24. No shutdown, exit, FA0/1, IP address 2.1/24. No shutdown, exit. IP DHCP pool A for the network 2.0 with a gateway address of 2.1. Let's assign IP address to the end devices. I'll go to PC0, desktop IP DHCP, PC1, desktop IP DHCP. Then I'll go to PC2, desktop IP DHCP. desktop IP DHC. Then we will configure EIGRP between these devices to make this network communicate with the other. I'll go to my first router EIGRP 100, no auto summary, network 192.168.1.0 0.0.0.255 12.10.1.0 0.0.0.255. Then I'll go to router 2, router EIGRP, no router EIGRP 10, and then router EIGRP 100, no auto summary, network 192.168.2.0 0.0.0.255 12.10.1.0 0.0.0.255. The neighborship is up. Once that is up, we'll try making communication from PC0 to PC2. We can see I am receiving my replies. Now what I'm going to do is I'll go to my router number 2 and I will enable telnet on this device. For enabling telnet, first of all, I'll put an enable password, let's say Cisco. Then I'll get into line VTY 0 space 4. I'll say login, password, let's say PyNet, login, exit. After that, if I go to my PC0 command prompt and I try to take telnet access of 192.168.2.1, I need to enter the login password, which is PyNet, and then I can take the access. If I say enable, I need to enter the enable password and I get inside router 2. So telnet connectivity is something which is possible from PC0 to this router, correct? Using an extended ACL, I don't want this PC to create any sort of telnet connection with this router. I'm fine if PC1 or any other PC makes a communication with this router over telnet. That's totally okay to me, but I specifically don't want PC0 to have the ability of creating telnet connection with router 2. Okay. What do you think? For this kind of restriction, which type of ACL can help me? Standard or extended? Extended ACL, correct? And we yesterday have understood and learned that extended ACLs are configured nearest to the source. So I'll go to my router number 1 and I'll configure an extended ACL here saying access list question mark. I have to pick a number from 100 to 199 to make it an extended ACL. So I'll say access list, let's say 101 question mark deny question mark. I have to specify which protocol I am trying to filter out. So I am trying to filter out telnet. Telnet is a part of TCP. So I'll say TCP question mark. Source address I have to specify. The source is a single host device. So I'll say TCP host question mark. Source address 192.168.1.2 question mark. Now I have to specify the destination address. What are the destination addresses which can be used for taking telnet access of router 2? So one IP that we can use for taking telnet access of router 2 is 192.168.2.1. And another IP that we can use for taking telnet access of router 2 is 12.10.1.2. So this I hope Sayyid, this addresses your question also. Like we are specifying the specific destinations where we don't want this traffic to be allowed. Otherwise, for other routers, it will be allowed. Okay. So I first will block it for 192.168.2.1. So that's my source IP. That's my destination IP. After that, question mark, I have to specify the wildcard bits. So I can say 0.0.0.0, or we can even go for 255 to completely block the whole network. Question mark. Finally, I have to specify what exact protocol from TCP I want to block, for which we use EQ. EQ is going to match only packets for a particular port number. So EQ question mark. Now I have to specify the port number of the protocol that I want to block. So telnet's port number is 23. Remember? So I'll say 23, enter. This line basically will block telnet traffic sourced from 192.168.1.2 for the destination 192.168.2.1. Similarly, I will block telnet traffic from the source 192.168.1.2 for the destination 12.10.1.2. Clear, guys? Now in my ACL, I have specified what I want to block, right? I also need to specify what I want to allow. So now I will add some permit statements. Access list 101 permit ICMP. ICMP is the ping protocol that we use, right? For the ping messages. So ICMP source can be any, destination can be any. So access list 101 permit ICMP any. Similarly, access list 101 permit EIGRP any. So I have allowed ICMP traffic, I have allowed EIGRP traffic because these are the protocols I want to allow the traffic for, right? Final step will be applying this ACL on the interface. Where do you think it would be appropriate to apply the ACL? We cannot apply it on a switch. Switch is a layer 2 device. ACL is a layer 3 configuration. FA00. And in which direction the packets will be received? Inbound packets, right? So FA00 direction in. So I'll go to interface FA00 and I'll say I want to apply IP access group 101 for the inbound packets. After that, if I go to PC0 and try to take telnet access of R2, which I was able to take earlier, this time you can see it's trying and after some time it's going to get failed. You see, connection timed out, remote host not responding. If I try from PC1, telnet 210, 192.168.2.1. This is also being denied. What do you think? Why is it happening like this? Because of the implicit deny, right? In my ACL, I have allowed ICMP, EIGRP traffic, but I am not allowing still the telnet traffic or the other protocols, correct? For which what we can do is we can add one more statement saying permit IP any. This will include all of the IP protocols. After that, I can try again and you can see it is allowing the connection. If I put the login password correctly, I'll be able to connect with my router too. There you go. But if I do it from PC0, it will not allow me to take the access because of the extended ACL that we have implemented. Let me know what questions or doubts do you have in this. This is how simply we use extended ACL for blocking certain protocols and allowing the rest of them. Now, if I ping from this router, that ping will definitely work. All the other protocol related communication will still go on, but for telnet, it will not allow PC0 to have the ability of accessing the router number 2 because I have implemented an extended ACL for that. Yes, Michael, understanding of port numbers are something which we will have to know to block or allow certain protocols using extended ACL. What are the other protocols for extended ACL? All the protocols can be used for implementing or filtering out traffic, be it EIGRP, OSPF, every protocol. Sure, I'll repeat the configuration. Don't worry about that. We have a question, want that break the telnet for PC1 to any other device. Sayed, see, the ACL command that we have added, it says that if the traffic is generated from the source 1.2 for the specific destination 2.1 and 12.10 1.2, then only deny it, right? It will also consider destination, not just the source. So that's why if it will be for some other router having a different IP, that connection will be allowed. So it's not going to break PC1's ability of taking telnet access. What change did I make to make it work for PC1? I allowed basically IP any, that IP contains all the remaining protocols, like all the other protocols. So I allowed the remaining protocols so that telnet can also be allowed for the other devices having PC1. EQ stands for equals to. Equals to 23 means from the TCP protocol, we are willing to block traffic of port number 23, which is used by Telnet specifically. So under TCP, there are multiple protocols. There is HTTP, there is Telnet, all these different protocols are there. So we have to specify which one we are willing to block. So 23 is the port number of telnet. That's why we are blocking that. Yes, Nicholas, we have completely removed for the whole network, but that's again not required. That does the same job though, because in my network, other than router, there is just my end devices. So it doesn't matter basically. But in case you want to be very specific, you can block, let's say, just 2.1 IP address by adding a wildcard mask as 0.0.0.0. Okay, let's understand again what we did. We were trying to block communication or being specific, the telnet communication from PC0 for the destination router 2, for which I created an ACL which looks something like this. Here, what I did, I said I want to deny the TCP protocol from the host 192.168.1.2 for the destination network 192.168.2.0 for telnet. Then I said I want to block this source also to have the ability of connecting on 12.10.1.0 for the telnet traffic. Then I said I want to allow ICMP, which can be generated by any source for any destination. I want to allow EIGRP also for any source, any destination, and IP, which includes many other protocols. I want to allow IP protocol as well from any source, any destination. Clear, guys? These are the matches count, basically the packets which matched this particular ACL statement. So 24 packets were denied because of this ACL statement. 4 packets were allowed because of this statement. 71 packets were allowed because of this statement. Yeah, if it is a specific IP, the wildcard mask we will use will become 0.0.0.0, as it would be a translation of subnet mask 255.255.255.255. So when it's a single IP, we go for the wildcard mask as 0000. I'm sharing a lab guide as well. You can refer to the configurations which I have pasted in the chat, or otherwise you can also refer to the lab guide which is here. Okay, I would quickly like to address a confusion which is there regarding the lab guide which I have shared. 4.1 is the IP of router 2, as well as it's not necessary to apply it on all the interfaces, which is correct. So you can just put it on the interface which connects to uh, the blocking network, and that would also do the job. You need not to put it on all the interfaces. Guys, let me know once you are done practicing extended ACLs, then we'll move to the next discussion. All right, moving ahead, we will discuss about another amazing technology, which is called network address translation. If you might be able to recall during our basics discussion or the discussions of network fundamentals, we spoke about two types of IP addresses, public IP addresses and private IP addresses, right? Today, we are going to learn about a technology that can help us in translating the private IP addresses into public IP addresses. So let me share my screen and let's understand what is this technology all about. When we speak about IP addresses, there are two types of IP addresses, public IP and private IP. Let's first of all try to understand the difference between them. Public IPs are assigned by an organization called INA, which stands for Internet Assigned Numbers Authority, whereas private IPs are assigned by the network admin. Public IPs are paid, you have to pay money for them. Private IPs are free to use. Public IPs can only be used in local area networks. Private IPs, sorry, I said it opposite. Public IPs can be used over internet and private IPs can only be used in a local area network. Okay. From every class, there is a range which is reserved as private IP range. Can you guys recall and tell me what is the range for class A, which we consider as private IP range? Okay, let me write it here. It is 10.0.0.0 to 10.255.255.255. That's the complete range which is reserved as private IP range from class A. From class B, this range begins from 172.16.0.0 to 172.31.255.255. Then for class C, this range starts from 192, 168, 0.0 to 192, 168, 255.255. The question is that how do we use these private IP addresses? So basically, we use them for local area networks. Let's say if I talk about my home network, in my house, I have a smartphone, I have a laptop, right? I have a tab, and then we have a smart TV on which I am using internet. As per the discussions, we have said that for using internet, we require a public IP, right? We require what? A public IP. So does that mean I'm using one public IP here, two here, third here, and fourth here? Am I using four public IP addresses to make these devices communicate to internet? No. We are using private network for connecting all these devices, which is free to use and can be used by anyone. We are using a private network for that. But then how come am I able to communicate with internet? That's possible with the help of the Wi-Fi router that I have. This router is configured with a concept called NAT, which stands for Network Address Translation, which allows me to translate my private IP addresses into public IP. So when we go to the internet or when we go to Airtel and ask for internet connectivity, they give us a cable connection and put a public IP on the interface. This public IP is what we use for speaking with internet. Make sense? So for translating all these private IP addresses into public IP, we use the technology network address translation. Now, network address translation can be implemented in three ways. One way is static NAT. Static NAT is one-to-one manual mapping. One-to-one manual mapping means one private IP will be translated to one public IP. And you define that what private IP will use what public IP. Okay, that's completely up to you. Second method of implementing NAT is dynamic NAT. This stands for one-to-one dynamic mapping or random mapping. In dynamic map, what you do is you define the pool of private IPs. Whatever are the private IP, you define them. Similarly, you define the pool of public IPs. And randomly, my router is going to translate them by picking up from the pools. Okay. Then we have the final and the most used method called PAT. PAT is also known as overload method, and this stands for port address translation. In port address translation, we can translate multiple private IP into one public IP. It is port address translation, which we use most of the times in connectivities like this. Only one public IP is there on my outgoing interface, but there are multiple private IPs which are there in my LAN side or in my home network. I translate all of them into one public IP, and approximately 65,000 private IP addresses can be translated to one public IP. And this happens with the help of port numbers. What does that mean? For example, let's say you have 192.168.1.1 as a private IP. You have 192.168.1.2 as the private IP and 1.3 as the private IP. Now you want to translate all of them into public IP. And the only public IP that you are using is, let's say, 8.5.6.1. Okay. Now, when you will do this translation, every private IP will be assigned with a port number looking like this, so that when we do the translation, we can differentiate and can understand that which packet is coming from which particular source. So we identify or differentiate between these private IPs using such port numbers. Is that clear how port address translation or the overload method of translation works? So we will try one example of port address translation. We will replicate a scenario like this only, where there's going to be a home network and I will implement port address translation on that home network to make it communicate with the internet. So let me share my screen again. Okay, Sham, if you have reached 65,000, then you will need another public IP for the further translations. What I'll do is I'll take one home router. Let's say this is my home router. This is my internet service provider router. This is the internet. Okay. And we have a switch. We have some end devices. Let's connect them together like this. We are assuming that this is internet. Let's say this is router of Airtel, the service provider I am using, and this is my home router. Okay. So inside my home, I'm going to use a private network. So let's say it is 192.168.1.0. But between my home router and the Airtel, there is going to be a public connectivity, a public IP connectivity, right? So let's say it is 12.10.1.0, the public network. And between Airtel and internet, we will assume the network to be 23.10.1.0/24. Clear? Now I will go and begin the IP configuration. This is my home router. I'll say no. Enable config T host name R1 on FA00. IP address will be 192.168.1.1/24. No shutdown, exit. On the interface FA01, the IP is going to be 12.10.1.1/24. No shutdown, exit. Next, I'll go to the Airtel's router, CLI, say no to the question. Enable config T host name R2 FA00. IP address 12.10.1.2/24. Then interface FA01 23.10.1.2, let's say, /24. Finally, I am on the last router, internet router, CLI, say no to the question, enable config T host name R3. On the interface FA00, I'll configure the IP address as 23.10.1.2. 23.10.1.3/24. No shutdown, exit. Now we are going to configure EIGRP here between these devices. But actually, in real life, which protocol do we use over internet? Let me know. BGP, right? We discussed earlier that there are two types of protocol. Internal gateway protocol, which includes RIP, EIGRP, OSPF, and external gateway protocols, which includes BGP. Now, BGP is not a part of CCNA. That's why we are not going to configure that. Rather, we will simply be putting configurations of EIGRP to make this routing work. In EIGRP, I will implement configuration just like we do in the case of BGP. BGP also works just with public networks. We are not allowed to advertise a private network in BGP routing. Why so? Any guesses? We can never advertise a private network in BGP or over internet because private network can be used by all of us. I might be using 192.168.1.0 as it is for free. I might be using it at my home for connecting multiple devices. And the same network might be used by someone else also. So if we advertise them over internet, there would be conflicts, right? There will be multiple packets coming from the same source, which is not a very optimal environment for a network, right? That's why we are never allowed to advertise a private network into the BGP domain. So keeping that in mind, I will configure EIGRP here, but I will also not advertise 192.168.1.0 into EIGRP. I'll go to my router number one. I'll say router EIGRP10, no auto summary, and I will only add my public interface, which is connected to me on 12.10.1.0. Make sense? Public IPs are unique. You will get it from INA and will be uniquely assigned to you. But private IPs are free to use. Ravi, I might be using this 192.168.1.0 network. And so also you might be using the same network, right? For connecting devices at your home. So there is no organization who is taking care of it, right? You can repeat or duplicate that configuration at your local area network. But when we speak about internet, we need to have a unique IP address. That's why we don't advertise private IPs on internet. External routing is just configured with BGP, not EIGRP, Anuj. We are looking at it here in this example using EIGRP because, like I mentioned, BGP is not a part of CCNA. That's why we are configuring EIGRP in the place of BGP. EIGRP also is used for internal routing only. So please either edit your message or delete it. Otherwise, someone else might get confused. So yeah, that's not internal. It's an external network. It's a public IP that we are using, right? So it's a external connectivity that we are assuming in this lab. 12.10.1.0 is something which is connecting me to my ISP. So that's a external connectivity. Here we have spoken about the private networks, right? So private network from class A is 10.0.0.0 to 10.255.255.255. 12.10.1.0 is not from that range, so it's an external IP. Similarly, 23.10.1.0 is not from that range. That's also an external IP. But 192.168.1.0, that's a private IP, correct? From class C. So we are not advertising that. We have just added the public one. Similarly, I'll move ahead on Airtel. I'll configure EIGRP just with my public networks. So router EIGRP 10, no auto summary. network 12.10.1.0.0.0.255 and network 23.10.1.0.0.0.255. Finally, the last router, I'll say router EIGRP10, no auto summary, network 23.10.1.0.0.0.255. Then I'll go to the PC4, and to provide IP on this network, I'll use a DHCP pool. On my router 1, I'll create a DHCP pool A for the network 1.0 with a gateway as 1.1. Let's try using DHCP. Yeah, we got the IP. Then PC5, DHCP, and we got the IP. That's okay. 0, 255 or just 255 makes no difference. That's okay. Now, after assigning IP to the end devices, if I try to make communication with the internet router, so for example, from PC4, if I try to ping 23.10.1.3, which is IP of internet router, I will obviously not get any replies, right? Why will that happen? Because my source 192.168.1.0 is not being advertised on the protocol, which is connecting me to the internet. For making it work, what I will do is I will configure network address translation. If I go and try to ping internet from my router, if I say ping 23.10.1.3, I am getting my replies, right? We can see success rate is 100%. Why so? Because router will be sending packets with a public IP 12.10.1.1. That's why when it reaches internet, we get the replies. But when I do it from PC4, the source of that particular packet is going to be a private IP, which is not advertised here. So my routers will not accept that message, which is coming from an unknown source. Okay. For which I will configure NAT on my home router so that these private IPs can be translated to public IP and then they can communicate over the internet. Clear? Are we all clear so far? What is the motive of configuring NAT? Okay. So let's begin. Let's understand how NAT is configured. Config T. First, I have to create access list. So I'll create a standard access list 10 permit, and I have to specify the network that I wish to translate. I'll say I want to translate 1.0.0.0.0.255. That's it. Okay. Then let me know on my home router which interface is facing towards the private network, FA00 or FA01. 00, correct? So I will go to FA00 and I will say this is IP NAT inside. Inside interface is that interface which is basically for the private side or the network that you wish to translate. Then which interface is facing the outside network or the public network? 01, right? So I'll go to interface 01 and I will say IP NAT outside. Exit. First step was creating the ACL. Second step is defining which one is the inside network, which one is the outside interface. Now is the time where we define the NAT rule. The command for defining the NAT rule is IP NAT inside. We have to specify the source. So source is defined inside the list, access list, right? So source list 10, and then I have to specify where I want the translation to happen. I want the IPs of my access list 10 to get translated on the public IP, which is on FA01, correct? So I will say IP NAT inside source list 10, interface FA01, and finally the keyword overload to specify that this is port address translation. Enter, and that's all what we had to do. Once that is done, I can go back to PC4 and I can again try to ping my internet, and you can see I am getting my replies. And this happened because I configured port address translation on my device. I can even see how the translation happened by checking the command show IP NAT translations. So you can see here that 192.168.1.2 got the port number 5 and got translated to 12.10.1.1 IP, which is basically the IP of FA01 for the destination 23.10.1.3. We can see all the translations also, which took place for all the 4 packets, which I tried to send from my source 192.168.1.2. This is how port address translation is configured. I hope that makes sense to all of us. If there is any doubts or queries, you can let me know. Otherwise, I'm sharing the lab guide. Test the same and let me know once you are done. Yes, every packet will be translated separately and might receive a different port number. Okay, guys, I will like to clarify again what happens when you are configuring EIGRP without wildcard mask. When you configure it without wildcard mask, it will pick up the default subnet. For example, if I say on my home router, if I put the network statement as network 12.10.1.0 and I do not specify this wildcard mask, it will pick up the default subnet mask and will consider that for considering the interfaces. Okay. So it will take /8 as the subnet mask, resulting the wildcard mask into 0.255.255.255. Now, does that mean that this network will be advertised to the Airtel router as a /8 network? No. When we add these network statements, we are telling the router about interfaces which should be participating in EIGRP. So if I say instead of 12.10.1.0.0.0.0.255, if let's say my network advertisement is 12.0.0.0.0/8. So will that include the IP of FA01? Yes. Even if I put it as a /8 network, in that /8 network, FA01's IP would be included. Yes or no? Let me know in the chat. Yes. So it will make FA01 participate in EIGRP, which fulfills my motive. So it won't make a difference. The reason we put these network statements is to tell the router about interfaces which will participate in EIGRP. So even if you add it as a /8 network, it will add EIGRP or will enable EIGRP on FA01, making it work. So that's why sometimes when you don't put the wildcard mask, still EIGRP neighborship comes up. Guys, PAT is used for translating multiple private IP into one public IP. You just have observed PC4 is able to communicate with the internet. But even if I try making a ping from PC5, so if I say ping 23.10.1.3, which is my internet router, I'm getting replies there also. It's only possible when we are using PAT because we are able to translate multiple private IPs into a single public IP. Clear? So even if you tried from PC4, if you tried from PC5, both the IPs will be translated into public IP. And we can verify that by running show IPNAT translations command. Here you can see my 1.2 as well as 1.3 both got translated to 12.10.1.1 only, but with a different port number every time. So that's how port address translation works. I hope that makes sense. It's a standard ACL, say. This time access list is not being used for filtering traffic, so it doesn't matter whether you are putting it near source or destination. It's being used for pointing, or you can say defining the private network. So the purpose is not filtering. Okay, another confusion here is that people are thinking NAT and PAT are two different things. Like I have mentioned earlier also, PAT is a type of NAT only. So when you are configuring PAT, which is port address translation, you are configuring NAT only. Okay, so these are just types of different network address translation technologies, and PAT is one of them. So you're not putting them together, or you're not putting them separately. They both are same thing. Is that clear? Show IP NAT translations. Sure. When we look at this output show IP NAT translation, it tells us different types of IPs: inside global, inside local, outside global. So inside global means the public IP on which you are translating. Inside local means the private IP that you are translating. And outside local, outside global is the destination where you are trying to reach. I don't have any issues in explaining eBGP and putting NAT over that, but that would require a good amount of time to make you guys all understand and introduce to BGP, which is not a part of CCNA. So that's why I'm refraining to get over there, as we do have many other important topics to address so that we can fulfill the main motive of this free training, which is making you guys CCNA ready. For eBGP, iBGP, we definitely have many videos on YouTube from where you can learn and expand your knowledge. All right. I think we are good with the concepts of NAT. Sayed, you can try to recheck your configurations. Possibly you might have made some uh, mistake in the configs. Sure. Let me show you the YouTube channel of PyNet Labs. And there are many topics, many discussions that can be really helpful for you all to understand how things work in the world of networking. You just need to go to YouTube and search for PyNet Labs. I'll just open the channel. This is the YouTube channel. Also, very important notification here for all of us who are learning networking and CCNA for the first time. There is an upcoming webinar which will be hosted by Mr. Dipanshu Budija. He has been in industry for years and is a great guy to learn from. So he's hosting this webinar about how you can get a job as a network engineer, which is going to be live, and you guys can definitely attend it to expand your knowledge and know how things work in the world of networking, how you should be applying for jobs, right? This will happen on 17th May. You can just keep your notification on for this one so that whenever it happens, you can just watch and enroll yourself, right, to the knowledge. So you will get to know how the free classes can be utilized, free knowledge can be taken. You will learn about how you can learn free CCNA, CCNP topics, how Google ChatGPT can help you, how you should be applying for jobs on different platforms. Other than that, on the same channel, there is multiple videos explaining different concepts of networking. There are various things on which we have already uploaded videos. You can check them. You can look through the CCNA questions, CCNA concepts, many things, right? Then there are playlists also, which can help you in getting expertise over certain topics. Yeah. So I'm pasting the link of this channel. You guys can have a look on it later on whenever you like to. All right. So this brings us to end of today's session. We have kept it short and simple for today as we discussed quite really important technologies, and I want you to practice that. Then in the coming week, we'll be speaking about all the remaining topics where we have got some discussions remaining on concepts SSH, wireless, we have IPv6. These are few of the major topics that we are left with. So we'll be wrapping up the training in the coming week. I am hoping that you guys are enjoying being a part of this training and learning through this training. And if you haven't shared your experience or review about this free CCNA training, then I request you to do that, as that keeps us motivated and makes us understand if we can do something better to bring a better content and better products to our students, right? So your feedbacks are really important. Your reviews are really important to us. If you haven't shared it already, so please take out few minutes today and let us know if you are enjoying the training or not. So thank you so much. With that, we are good to wrap it up and we'll see you all on Monday. So enjoy your weekend. Take care. Bye bye.